store. Okay, so how do we do this? Actually, we first we take the code, we generate a call graph of the code, and we identify the interface methods of the service, and also interface methods of other systems, because you shouldn't only look at your system, you should also look at the interface methods of other systems, because your system's methods are communicating with the methods of other systems, right? And plus also some Java I/O library methods. And in our case, the service we analyzed had 26 other system interfaces and 126 methods, internal methods. And so remember, we have to compute two things, right? We have to compute the damage potential ratio, the damage potential of each individual method, plus the effort, right? So in this case, in this application, we had to look at the sources of input instead of privileges. In case of C-based applications, when you do the attack surface analysis in C-based applications, you look at the method's privilege. But in our case, privilege was not useful, because the entire service was running with the privilege of the application server on which the service was running. So we didn't have fine-grained, privileges. That's why we had to think about, okay, what should we consider here when we measure the attack surface of the application? So we looked at the sources of input. What are the sources of input? Source of input includes things like input parameter, right? Because a method had some input parameter, receives some data, or returns some data maybe, and also calls other systems, and also communicate with the data stores. So for example, if you look at the SQL injection and cross-site scripting, what happens there is a method receives data items from an attacker as an input parameter in case of these attack types. So then it makes sense to consider sources of input in order to compute the damage potential. The same thing applies to another attacks, like a method receives data items from the data store in case of file existing check attacks, right? The attacker wants to know, oh, does this exist, or not? So in this case, the method needs to invoke or receive data items from the data store. So in order to compute the effort, we look at the access rights related to the methods. So for this purpose, since we have two types of interfaces, internal, public and internal interfaces, like public interfaces which can be called by other systems and from the environment, and internal interfaces which can only be called by the application itself. And that's why we look at two types of access rights, public and internal access rights. So, so the interesting thing is now, okay, let's say we identified these things, and how do we now compute the damage potential? So we somehow need to assign some numbers. For example, is input parameter more important than data store and other system? Because we somehow need to give some weights, to these kind of inputs of resources, which are very important to compute the damage potential. So what we did actually, we looked at the threat modeling, which has been done in the context of the SAP service, and we tried to understand what kind of attacks are possible in this kind of applications. And we found that parameters, for example, are extremely important. As I said, for example, SQL injection, cross-site scripting are misusing the input parameter of a method. That's why we gave some weights. But I'm not going to talk about why we really gave 5, 3, and 1, or not something else. So there is a sensitivity analysis technique which has been developed at CMU, and we used their methodology and experiments to give these weights.
But I have one question.
Sure.
Which is the following. So okay, suppose I consider a method. Okay, so really the risk depends on what the method does, because if the method is a method accessing a password file, then the risk of giving a bad parameter, like in the case of SQL injection, would be very high, not because of the parameter itself, because of what the method is going to access.
Right. So the method has, in this case, had high potential, damage
exactly, but this is not implicitly given. It's just because the method will access certain very sensitive resources.
Yes.
If another method doesn't access sensitive resource, then it can be attacked, but it's not really a serious
Exactly. That's
problem.
why we have
So
to know.
how do you tie, those numbers to the actual actions that the method will do? You see what I'm saying?
Yes, yes.
Okay.
Actually, I skipped that part, but you somehow have to have an understanding what your code is doing. That's why you really need to look at your code. So, and since you wouldn't probably have hundred thousands of methods, accepting user ID and password as input, so you have certain points where you do some authentication checks and authorization checks. You have to know these methods, and of course you will assign higher values to these methods. So we do kind of annotation of the code, and then generate the call graph.
Yeah, but again, I don't know whether starting from the code is a good idea. Because in my view, I would start from the resources I want to protect. So say, I want to protect the password file, okay? And then after that, I needed to look all the code which accesses. While you are suggesting to do the opposite, I look at the code by itself. That may be much more expensive to do. But,
yeah, I mean,
no.
Otherwise, how can you understand the semantic, of the code? You really need to distinguish between the methods which might have higher contribution than the others.
Exactly. Once you know which are the sensitive resources,
Right.
which I mean files or other resources, then you have to syntactically see which are the methods which access that particular resource.
Okay.
And once you have done that, then you can look at them, those methods and really see what they do.
I see. But you may have,
Yeah.
if you have this knowledge,
Yeah.
if you really have this knowledge, which method is accessing which,
Yeah.
sensitive data.
Yeah.
So you could definitely, inject this knowledge
Okay.
into the analysis. So in our case, in this case study, we had some assumptions, of course, and constraints, etc. So we thought that this is the best working approach in the case of this test case study, because it always depends on how the application is implemented. Is the authentication authorization checks done within the code, or is it somehow separated? Do you really know if your code basis is 50,000 lines of code, for example? Do you really know where these kind of checks are done or not? So it depends really on the application, and your approach might also work.
No, but I'm talking exactly. My approach really, no, it's not really my approach, but in order to compute those values, it would be more sense to tie that to the actual resources accessed by method or applications.
Yeah, I agree.
But,
Yeah.
okay, but that's all. Okay.
Lawrence?
Okay.
Okay. So we implemented a tool because the goal of the research is not just to understand how attack surface measurement works. We want to give something to developers which they can use when they add new code, or when they remove code, or when they add patch. There are different use cases how attack surface measurement tools can be used in application development environments. So we wanted to develop a tool with which we can do this analysis, and it's a kind of Eclipse plug-in. And basically, what the developer needs to do is he says, okay, I have 50,000 lines of code, but I would like to do the analysis on this part of the code. He can scope the code and then just click the attack surface measurements button, and then he gets the result computed. Of course, in order to do that, you have to feed the tool with some configuration data. In this case, you have to list the you have to feed the tool with the list of Java IO libraries, and feed the tool with the list of other systems interface methods, right? And also this numeric value assignment we have been talking, right? Because that input parameter is more important than the data store, for example. So we did an experiment with three versions of the service, and then we found that the latest version of the service has slightly bigger attack surface. But the good thing was here that if you look at the service 3 and compare it to service 2 and 1 earlier versions, what the developers did actually, they defined 4 you know,